Hey, welcome back. This is another video for Class 6. I'm not sure how much of this we'll be able to get through, but I did want to cover some worm gear information here. For discussion only, no assigned problems. Worm gears are useful to transmit loads. One of the nice things about them is that there's a really large gear ratio that are taking place. Now, there are a lot of reaction forces here that we have to account for. They are very inefficient kind of gear. Like you usually wouldn't run something at a high speed, but I guess you can, and there probably are some. Well, let me take that back, because actually my worm gear broke in my snowblower, and apparently that happens a lot. And I haven't fixed it yet, so I've been looking for a replacement gear instead of buying the entire assembly. So what in the auger inside the snowblower, which is like a kind of a corkscrew piece that gets turned and kind of draws snow up into the snowblower, where then it gets like spit out through a kind of an impeller type of thing. But the auger kind of pushes up the snow into the impeller to drive it out. But that's driven by a shaft that's coming straight into this little gearbox, and then out to the side is the axis of the auger itself. And mine broke. And then I took it apart and opened it up, and sure enough, all the teeth were all on the gear. Were all gone, because it was made out of bronze, whereas the worm was made out of steel. So I should have brought that in. Damn, a lost opportunity. But I've been looking for a replacement gear online, and I haven't found one. But there's a John Deere, and John Deere wants like $675 for the entire assembly. Whereas I found similar little gears, this little bronze gear, for other snowblower that are like $10-15. So I keep trying to find a replacement gear for this. I was thinking about trying to find one that's the right size, but I don't really have the parameters, so I'm gonna have to try to look and try to actually work through this. So it'd be a good thing to try to take care of. So we have this worm gear, but yet, so that's a relatively high speed operation coming in, but it does reduce the gear a lot, right? So the worm could be traveling really fast, but the gear is going to go kind of slow. And it does have these side forces that are taking place. So I have a demonstration worm gear somewhere. Oh, it's on here. It's on the ground. So let's take a look at him and see what some of his features are. First off, kind of interesting, they have this like little arc coming in here, right, to allow for the operation. Here it is from the side, and we can see. I mean, you see how many turns that I'm making here, and see how slowly that's going, so we can already see. But you can even hear. There's a lot of rubbing going on right there. So there's a lot of, like, this could be a very inefficient thing. It could generate a lot of heat. So this definitely needs to have a lot of lubrication as part of the thing. But there's sliding taking place right along there. So it's really like bolt threads almost. You could kind of think of them as bolt threads, and then the gear is riding along onto them as we're coming through. And then, like as I mentioned, this thing has this kind of this shape right here, and that allows this thing to operate. One feature that you should know about worm gears is that you can't turn this by turning that. Right? So there's this sort of this locking kind of thing involved. You shouldn't rely on that. You should have like a brake or something in a machine. But you could. It is a means of stopping the thing from ever going in reverse. But I think if this angle was like, this is a very low angle. If it had a very tight angle, there might be some ability to make this thing turn. But I don't think so. But there is caution in the book when reading in this section that says that don't rely on that locking nature onto the thing. Now, there are quite a few equations right in here, and of course they're not really all that useful to us unless we try to work through them. There are these angles that we want to care about. There's this lead angle, lambda, So I could measure that probably, or get close to it, measuring it on my snowblower to make sure that I'm buying the right one. The pitch diameter is something I need to figure out right in there, and the axial pitch that's something I could measure the axial pitch, and I could measure my estimate my root diameter. I can estimate my helix angle. I think right there. Of course, that should be the complement should be the lead angle. And then you could measure your lead. And by the way, the lead looks like to me it should be the same thing as the pitch, the axial pitch of this, right? So anyway, here's another view. I liked this one right here. You can kind of see the sliding. There's the transmitted, and we have the axial, and we have some radial. So you see the worm driving as part of that. And for a force analysis right here, this always interests me. I'm trying to figure out what this cone is supposed to be. This is the pitch cylinder and the helix, the pitch helix that they're showing right here that's coming along. So as they're trying to show this, and by the way, they're showing the efficiency is an important consideration. So here is your efficiency. It does rely on a coefficient of friction as part of understanding what the friction is going to be. When we get into bolts, power screws specifically, this is going to be very relevant type of thing. So you might almost, before you're approaching the force analysis for the worm gearing, actually go back and go back. Well, we haven't gone it yet. Go through the power screw section of the book. So that's back in, I think it's chapter 8, I think, maybe. I think it's in bolts. But anyway, once again, we have a free body diagram that we want to place. So if we have an input torque, well, we have to be careful here. Let's see. Here, here's X, and here's X. Okay, so there appears to be an input torque. No, that's got to be an output torque. This has to be the input. This torque, this T right here, he must be the output right here, the one that you're seeing right here. That's the destination, the thing that we want out of an example problem. So anyway, this one is coming in and it's forming. Ooh, I can barely see that. Let's say this is a WG. This looks like it's the. Well, we're gonna, of course, once again, when the shafts are perpendicular to each other, one of them is one's axial is the same one as the other one's radial, right? So you have to the transmitted will always be the transmitted. So this one right here will be transmitted, but like this is radial. Let's see, am I saying that right? No, that's not going to be true. Okay, wait a minute. Let me think right here. Okay, so. So here, in this case, the transmitted is the axial, right? Depending on which one that you're looking at. So the worm's transmitted is the gear's axial. The worm's radial is the gear's radial. Okay, those will be the same. But the worm's axial will be the gear's transmitted right there. Okay. So that's interesting, right? But the gears transmitted is probably the one that we care about because that's the one that we're going to have the torque related to each other. And then so looking at this guy right here, we could kind of get sort of an idea of the shape of that that's taking place. I want to figure out, and I want to figure out this cone a little bit better, or maybe it's not a cone. Maybe they're just trying to. Yeah, they're calling it a cylinder, so it's not a cone. Why are they showing it as a cone? Maybe they're just showing it with perspective. I think that's what that is, yeah. I think it's supposed to be a cylinder, and they're just showing it with perspective. Interesting. So I'm learning stuff as I read through there. That's not the best way to teach. So class starts in 10 minutes. There was other things. The first from excerpt from Boston Gear Catalog, where we take a look and where we're trying to find how to tell a left hand or right hand worm gear. Oh, that's a good thing. I'm going to need to know how to do that right there. Threads on left-handed lean to the left when standing on either end, and on the right they lean to the right. Right. So you want to make sure that we have this. Make sure that they're compatible. And here's formulae that you would use when finding worms for the gear. So I'm going to need to use these probably to figure out how to fix my my snowblower. And then they also have efficiency in here. All right. So this is kind of a cool thing. I want to remember to introduce the Boston Gear Catalog as in our class. So I made these for posterity, but also as a part of my class prep to try to see what I wanted to present. But also, I'll leave it up here for maybe people want to learn something about worm gears, and I wanted to walk through it. So thank you.